Okay, so I want you to use the graph to evaluate what this area is. So understanding that this definite integral means area under the curve, let's graph y equal the square root of 4 minus x squared. You know that that is a half circle of radius 2. So there it is. Oh, and look at that. This is saying find the area under the curve between -2 and 2. So it's talking about this area here. So think shapes. Think shapes. This looks like a half of a circle. So 1/2 pi, radius would be 2 squared. All right, so let's look at the graph of y equal the absolute value of x minus 2. So you know that that's the absolute value graph shifted over 2. So if I'm looking for the area under the curve between 0 and 5, I'm looking at this area of that triangle here, and I'm looking at the area of this triangle here. So this triangle will have an area of 1/2 base times height, right, using the y value that's given here. And then this triangle will have the area of 1/2, base will be 3, and height will be, if I plug 5 into the function, I get 3 as well. So this gives me 4/2 plus 9/2, or 2 plus 9/2. Okay, a little bit more challenging of a graph. So this y equal 2 plus the square root of 1 minus x squared is the half circle graph, right? Half circle, this by itself would be this graph here, right? But it's being shifted up by 2. So it looks like this. All right, so what I'm looking to find is the area between -1 and 0. Okay, so I know that this has a radius of 1, so this goes back to -1, and there's 1. So between -1 and 0, I'm looking at this area here. So let's see what I've got. So I've got this quarter circle, and then I have this rectangle. So I'll need to figure out both of those individually. So the quarter circle will be 1/4 pi r squared, and the radius is 1, plus this rectangle will have area, width times, right, if I have width or height, or length times width. This distance here is 1, and this distance here is 2. So I get 1/4 pi plus 2. All right, so let's look at this graph of y equal x minus 2. You know, it has a y-intercept of -2, and I'm looking to find the area between 0 and 4. All right, so that means I'm looking, so the area is from the curve to the x-axis, the curve to the x-axis. Now recall, if the area is below the x-axis, we give it a negative, right? There's a negative assigned to it. It's called negative area, right? That was from Riemann's sum. So this area here, since I see it's below the x-axis, this will be negative, and the area of that triangle will be 1/2 base. So this will be 2 this way, 1/2 base, and this distance here will be 2 as well, 1/2 base times height. All right, let's look at this area here. This area is above the x-axis, so I'll be adding on 1/2, and this distance is 2, and this distance is 2. Oh goodness, so they end up canceling out, so I get an area of 0. So this negative area cancels with this positive area. Right, so if I'm looking at the graph of y equal x plus 3, here's 3. Oh, and what am I trying to find the area between? 1 and 1. Well, what's that going to be? 0. There's no area to find. All right, I'm going to take a moment and put this on the next video when I'll have the graph drawn for you.